Time for my regular visit to the biggest HVAC trade show, and I just get to wander around and look at what I think is amazing, what I think raises a lot of questions, what I think is majorly problematic. So let's get to it. Ceiling fans are an incredibly important part of your HVAC system. New blower door system. How many CFM does that thing push? That fan?
This setup is like a 2000 CFM. Yeah,
okay.
But we try to develop the bigger, you know.
Yeah, okay, cool.
So, yeah.
One of the cool things you can find at the show, which you wouldn't find in real life, is test instruments, like new test instruments that I haven't seen before. All right, Jim, what in the heck is this thing?
So what we have is basically in what we call our ultravision. It's an acoustic imager for finding air leaks or mechanical leaks, like bearings. We know they'll fail up around 42
Is
kilohertz.
it an ultrasound? Like it's
It
measuring...
does acoustic, but like we can filter just to where we'd find bearing frequencies. I can see right here I got a peak at
So
that
right
frequency.
now, as I'm understanding, you're saying that there's like 2 microphones?
128 microphones.
128 mics. So you've got a Dolby Atmos microphone system here that's doing triangulation. Right.
So it cuts everything else out.
Okay,
I can expand that out, and then I can bring in more noise, like look for air leaks. There's all kinds of different detections. So like we'll put a tone generator inside the cab of a plane, and we can see if there's leaks in windows, things like that.
Now, the manometers, these are designed for HVAC. So if you're gonna buy one of these and intend it to use it for home performance pressures, you wanna look at the specs on this. So like, here's the lineup, and you wanna look at the unit selection. So this is kilopascals. That's 1,000 pascals at a time. You want to, in homes, you want to be able to measure down to 1 pascal, or even less than that sometimes. So these are not designed for the purpose of like zonal pressure testing, for example. So you wouldn't use these for that. They're for HVAC pressures, which are much, much bigger. And again, it'll give you a clue. Like if you look at the pressure range, 60 inches of water column, there's 250 pascals in an inch of water column. Another thing that's really interesting, so people ask us, we have this carbon monoxide video that I'm looking on screen right now. This is a personal CO detector that you would wear. It's like belt mountable. And so this is pretty because it's black. I could wear this with a suit. A lot of them tend to be orange colored, which is not my favorite. But this right here is a low-level carbon monoxide monitor. There's not a lot of these. I tend to recommend, there's another brand called Defender. That's about 200 bucks. This one supposedly is 150 bucks, and it's smaller than the Defender, but it also has this interesting thing. So it'll alarm when this number hits 10 parts per million, it'll alarm. So you can see the peak over the last 24 hours, and you can see this. And this number is supposedly the number of the parts per million you would have in your bloodstream if you breathed this air for 24 hours. So it's the carbon monoxide in your hemoglobin, or carboxy, I don't even remember what they said, but. And then this is also pretty cool. This is a vibration sensor, so you don't have to have somebody who's highly trained to assess whether a pump or a fan is off balance or is, out of kilter. We got to have more people in the HVAC trades, and so tools like this that make it easy for people to not have a master's degree in how to analyze this stuff, not be an engineer themselves. You could give tools like this to your maintenance guy, and he could use it, once a month and see what's going on with the preventative maintenance schedule, so that then we know when to call people.
You gotta take a picture.
Brent Ridley.
What's up, Corbett?
You were right. I was wrong.
Oh my God!
That heat pump at my parents' house did not need the heat strips on the design days.
That was that experience coming in there, my friend. I think Mitsubishi has those things really conservatively rated.
I just talked with them, and I don't think they
think?
rate it, and AHRI rates it, and I think that actually it might be that Manuel J's assumptions are wrong and like way wrong. I mean, basically, just as a review, this is going to be in another video, but the house needs 65,000 BTUs per hour. It has 30 installed with that heat pump, and it held 70, no problem, for 3 days.
That's
while
awesome.
we had design day temperatures.
That's awesome. I knew it was going to.
So it's double. It's like oversizing by double. Okay, cool.
That's awesome. I'm glad to hear that it was working well. You
thank
didn't
you
need
for.
it.
Yes,
I couldn't talk you into it that day, but I'm glad you accepted it.
Oh, I know, but this whole channel is about the science of homes, and it turns out that the scientific assumptions that we're making are actually wrong, which is always important to know. That's what science is.
We can't be perfect.
Yeah, we could do better.
We can try.
We could do better. I'm going to talk more about that.
Awesome.
Like I said, there's a lot of stuff that's commercial here, but the applications are very interesting. So this is 75F is the name of the company, and what they've got basically is this series of controls. So they've got a pressure sensor over here that they can kind of measure the flow out to each one of these rooms in this office, because Bob, for example, wants his office to be between 66 and 79 degrees. Bob he's a rugged mountain man. And so he has a different preference than the people over here. And this is something that I hear a lot in homes too. People are like, well, I want my bedroom to be at a different temperature than the outside. I don't actually think that's true a lot of the time. I would challenge most of us to like look at what we're actually experiencing and what we think we're experiencing. But if you want that to happen, then what you need to do is have these dampers that are closing off certain rooms and all this stuff. And the problem that you get when you do that is that you're going to be changing the performance of the system. Since they're monitoring the performance of the system, they can be like, okay, system, ramp down because we've got a lot of dampers closed right now, even though it is hot in the space as a whole. So that's one interesting thing. A second really interesting thing here is that they've programmed this thing with AI essentially, so that when you first kick this on, this whole system becomes active. It's going to be a little clunky for the first couple weeks because they've done without this actually. What they can do is instead have the machine look at how Bob's office is performing, and then once Bob's office gets too hot, they'll just close the damper off and wait for the temperature to drift down a little bit, activate it back on. But what they are able to do is over the first couple weeks, it's learning how, when this one kicks off, what it does side effect wise to all of the rooms in the house or in the building. And then it starts to like adjust itself and recalibrate and say, okay, well, if I'm going to do that, it's probably going to have these side effects. That I think is brilliant because you're now able to have the side effects be programmed and be preventing these invisible dynamics that are like totally measurable. But unless you have somebody looking at what is going on a regular basis, it's really hard to do that. So in the future, I think possibly we might have this work in homes where like, oh, this room heats up a lot faster than that one does for some reason. So we're going to use that information moving forward. Let's keep going. All right, for all my tiny home and like school bus conversion clients, which you know who you are, here is a little 600 BTU, 600 to 1800 BTU compressor, which is the outdoor unit of your split system. They do not make, when I built my tiny house on wheels, I did not find this. I was looking for something like this. We ended up having to put a half-ton Mitsubishi in, which is 6,000 BTUs per hour. It runs down to 1,700, but this picks up where that one left off and goes down to 600. This would be more right-sized for my application. That said, it will work, like the Mitsubishi works. But look at this. Isn't that adorable? It's as big as my hand. This is the compressor for the outdoor unit. So the idea is you mount this thing on the outside of a van conversion, or in this, they made this explicitly for tractor trailers, right? Because they need to sleep in the bunk inside of the cab of their truck. So anyway, I think this is really adorable. It's going to end up on the indoor unit. It'll look something like that, and it'll distribute the coolness inside. They also have heat pumps, so look into this. It's called Masterflux by Tecumseh. So on the heat strips conversation with the heat pump,
right.
Bill is in a very different climate than Atlanta, where my parents' house is at. So where are you?
Pittsburgh, Pennsylvania, climate zone 5.
Okay, and if you don't know, Bill Spohn, True Tech Tools, one of my first interviews on the Building Performance Podcast.
That's right, I remember that.
Longtime friend,
yeah,
yes.
From an iPhone interview.
He's slept at my parents' house in Florida. So essentially, you also have turned off your heat strips now.
That's right. It had them on for a very brief period of time, but we have a 2-ton air source heat pump and a very well sealed house, and we only ran into 2 days last year where a combination of the wind and the outdoor temperature caused us to get a little chilly inside and drop about 2 degrees on our 7-1.
And you guys are rugged, so you put on sweaters instead of turning on your heat strip.
Yeah.
You didn't even turn on the heat strips.
We started running around chanting.
Don't I look really dashing with this? I love it. This is actually pretty interesting. So that's a mini split. We all know what that is. This is not the same thing. So you can see there's actual filters up there. Those are going to be in the next iteration of this design. This is Sharp makes this. These are going to be MERV 14 filters on a mini split. Mini splits have MERV 3 filters tops because you can't limit the airflow. So what they had to do to get the airflow out of it was to build 4 fans instead of 1 long fan. So like this is the kind of conventional one. This is like the ones that I have at our place that are Mitsubishi mini splits. They go through silly little filters that are just there to protect the fan. But here we've got these MERV 14 filters. The MERV 14 filters are going to keep the dust off of these blower wheels. So in a typical mini split, air comes in, passes the coil, and then hits the blower wheel. That air is now colder and is wetter, higher relative humidity. Also, this fan is surrounded by the coil, so the fan wheel itself is also colder, so it's more likely to condense water. And so this thing is going to get moldy after a while. Here, the new thing that they've done is comes past the filter, hits the blower wheel, and then it sends it past the coil. So this is going to keep this warmer, and it's receiving the same humidity air as is in the room. And in heating mode, it opens up at the bottom and sends the heat out like that one right there, so that it goes low in the room and then buoys up. Not a part of the show, but I think that's pretty cool.
Thank you very much.
There's heat pump water heaters here. There have been heat pump water heaters at these shows for a long time. I'm not going to show them right now because they don't have a piece of information that I think is super important to talk about, which is how much cooling they create in the room that you install them in. So it'd be great to be able to have a number to put into our HVAC design software. Even if it's not going to be as accurate as it possibly could be, it'd be nice to just have a number, because guessing with good information versus guessing with no information is a very different thing. So this is my friend Kevin Demaster at Mitsubishi. The 30 kilobtu heat pump, I've already gone on about this in this video, works when it's supposed to need 65. 1,000 BTUs per hour. Deactivated the heat strips. What in the world? What are your thoughts?
So one of my first initial thoughts is we hear a common issue in the industry when trying to use some of the manual J calculation tools, that there's enough buffer that they're building into those calculations that you're already getting enough extra tonnage or load built into the calculations, and they don't do as good of a job maybe with products like Mitsubishi Hyperheat. And what then also happens on top of it is sometimes the contractors still may not have peace of mind, so let's just add a little bit more load. Now, if you went by the book, I think, part of it just demonstrates that manual J, can be already doing some oversizing just to compensate, just like to give them 100% peace of mind.
Oversizing.
Yeah.
But the thing is that like municipalities are sometimes requiring emergency heat to be built in.
Yes.
They can add up to 85% of the load that is required. So quick thought about the difference between geothermal heat pumps, which are supposed to be like way, way better than air source heat pumps. Now, today, technology, do you think that they stack up together?
I think geothermal is just fantastic technology. It always operates in the sweet zone of a heat pump, right? I mean, when you're dealing with ground temperature, you don't have a wide range of flexibility, and a heat pump loves that temperature range, so it's only going to perform at its most optimal temperature almost all year round. The downside to geo is it's just the cost. And what does the underground look like for you? Air source heat pump, there's an abundance of air, and the air is pretty much all the same, except that it's just different temperatures. And when you look at seasonal COP for the cost, I think air source heat pumps, that's why they're getting so much more attention than geo.
So here we are with geothermal. I have not had a lot of experience with geothermal. I've lived in Chicago. Now we're in Atlanta. I have lots and lots of clients who are interested in it, though, and I've kind of been a little bit, a little jaded about it, because it seems like the sustainability, like the solar, when I used to hang out with solar people, we're not really on the same team all the time. But a couple of things I just learned are kind of interesting. So first of all, WaterFurnace is the most efficient manufacturer of the geothermal manufacturers. The indoor unit is going to be a lot the same as the normal air source heat pumps like a Mitsubishi. You got to change the filter, you got to maintain the thing, but they've incorporated a couple of interesting things. So first of all, this is their portal, their contractor portal, and you can go in and actually do troubleshooting on temps and water flows and things like that. So the major upfront cost of this system is going to be digging the holes, because you don't know how many holes you're going to have to dig to actually be able to get down to the depth you want, blah, 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 all this stuff. It costs generally like tens of thousands of dollars to dig these holes for the well. But the pipe that they use is rated for like a 500-year life expectancy, which is, I don't even imagine, that the house is not going to last for more than 100, 200 years, no matter how well you build it. And I tried to build mine really well. So that's one thing, is that like you're doing an upfront cost that's pretty significant, but that geothermal well system that lives with the house forever and then with the property once the house is gone. That's kind of interesting. Also, those pipes are welded. They're heat welded, so there's no mechanical clamping anywhere, so there's the likelihood of a leak in the geothermal loop is apparently pretty low. So I just saw one of the most amazing HVAC designs I've ever seen, and it was a geothermal system that was spec'd for this, which is why I kind of got like re-interested in this, coming to this booth. So that is insulated sheet metal duct. This is called duct board, and the thing about this is that if you're not careful, and a lot of people aren't careful, and if you put a video camera, a little borescope, a little video camera as big as that, inside the ductwork, you could see where the exposed fiberglass is just like ragged cut and exposed to the airflow inside, which is, I'm sure, flaking off little bits of it. So unless you've looked inside of these things, if you've got this in your house, I would probably assume that it's got some nasty stuff going on inside. Speaking of cool ducts that could make your house prettier, I mean, maybe you don't want to advertise for Chicago or have a tree, but you could make custom art and put it on your loft-style exposed ductwork. There you go. I have this problem where we got biofilm, which is a beautiful thing because bacteria need homes too, and they are amazing and blah, blah, blah. I love it, but in the drain pan of my air conditioner, in the drain line, which we had a flood, my drain line backed up into my studio and then flooded my studio this summer. Not super happy about that, but the solution right now is like you take these little pills that are chemicals and you put them into the drain pan. That sounds really easy, except that getting access to the drain pan is actually pretty difficult for most people. Homeowners are not going to do that. Professionals would need a few minutes and some tools to get in there. So this is Joe.
Hi.
Joe's got iFlo. So tell us about the iFlo.
So iFlo is an automatic AC drain line cleaning system and an AC drain pan cleaning system that I invented.
So it's not just the line, because this one shows the line, right?
That's correct.
So this one is, so you get chemicals,
Right.
that is the same thing that you put in the pill.
Well, no, it's completely different. than
Oh,
that.
wait, okay, tell us.
Yeah, this is it's an enzymatic product,
Yep.
which is specifically designed and engineered to break down zooglea, which is that thick biofilm that forms inside the AC drain pan and it clogs up the drain line. Right? The air conditioner shuts down, and the drain pan overflows and spills all over the place and Rougeau, and it floods the whole area.
And Joe knows this because it happened to him.
Oh, yeah,
And
many
then you
times.
understand that the zooglea actually like glued shut
The float switch.
The float switch,
That's
which is the thing that's like the fail-safe to make sure that the thing shuts off if it does flood.
That's right.
But it glued it
It
shut.
closed. Well, that's
Yeah.
what happens, right?
The coils are made out of something different than they used to be made of. So
That's
like
right.
my grandfather's air conditioner did not do this because
It used to be made out of copper. Copper's antimicrobial. It would kill those little the little biologicals. Now it just grows.
okay, so this thing is robot controlled. It's
That's
going
right.
to squeeze little bits, however much is actually required, into the drain line. But then I'm worried about the drain pan. So how does the drain pan?
Let me
get
show you
this?
this one right here. Right? See right here? This little silicone goes into the drain line itself. It goes upstream, so it's inked upstream. What's going to happen? You snap this right in, follow the arrows. You snap this on, and when this dispenses, this fluid is going to go inside. It's going to go into the drain pan. Then it's going to flow back through the drain line itself, free up the float switch, and everything is clean. And it does it automatically every month. But can also automatically order another bottle and send it right to your home.
So a homeowner could easily maintain this themselves. They don't have to be calling their HVAC contractor.
That's
No offense,
correct.
HVAC contractor, but you guys are so freaking busy already. We don't need you going out just to replace bottles. I like anything that makes it a little bit easier for people to maintain these systems because maintenance is life. You must do maintenance. You cannot, there is no such thing at this entire show that's like completely maintenance free. First, That guy's hilarious. That's John Whitehead from Iowa. If you're looking for HVAC, are you on HVAC list?
Honestly,
You on my list? You got to get on my list. All right, cool. All right, so this, though, I walk by, this says the world's most accurate load calc. And me, being kind of a little upset about this manual J thing, I was like, all right, tell me more. So I know Anthony, and he's like, oh my God, hey, how's it going? Look, this is our new thing that we've got. So I'm gonna hand it over to him.
This is TrueLoads. It's a residential load calc software. It's using the most accurate AHR method, the heat balance method. All the commercial calculation programs have just moved over to the heat balance. They moved away from CLTD over 10 years ago. Manual J is that hand count simplified CLTD from the 1980s. Really hasn't changed much. So we got to be better. We got to be more accurate. Manual J's were great. I made a living off of manual J's, but they're hand calcs, they're simplifications, they're assumptions, they're approximates. Here, we actually build your wall construction. We could do double studs, we could do thick ICFs, any SIP thickness and material. We have your U factor calculation. You don't have to guess. You don't have to guess on or figure out what your CLTD group is because it's got the thickness and mass of the wall. It figures out the time lag. Your peak heat gain could be at 8 o'clock in the evening, even though the outdoor temperature peak is at 2 to 4 o'clock. We've got more compass directions. So when you're not just 4 or 8 compass directions.
And to put an ERV into Manual J in this current software that I use, which is RightSoft, I build a box and I label it ERV, and then I have to fake these ducts that it's like, I don't know what you're doing, but I'll draw something there if you want to. Yeah. But it doesn't dump the actual air into those ducts. You're saying your software will be able to do
We could do independent ducting of the ERV or the HRV. Of course, you can have it part of the system. We'll size dehumidifiers for you. Not just you look at the numbers, it'll also be an equipment schedule with your mechanical. So your equipment schedule will have your dehumidifier. It'll also size humidifiers because it looks at latent losses. If the outdoor winter air is drier than the indoor air, we're going to have a negative latent gain or a latent loss. And then you can size the dehumidifier. You can have your dehumidifier saved, so you pick which one you want. But you're going to see the capacity of the dehumidifier and the humidifier, and then you're going to match that up with your latent loss, latent gain.
Awesome. Well, you'll see more of this on the channel. I'm definitely going to play around with this. Thank you very much.
Hey, thank you so much.
My friends, this is my HVAC trainer when I go to train on HVAC design, Alex Meaney.
Yep.
Hello.
Hello.
Okay, so we've got this running through line on, I'm upset that the Manual J told me I need twice as much heat as I actually need in my parents' house.
Okay.
So give me you were like, I have some thoughts.
Yeah. So traditionally, when you did heat load calculations, this was for everything, for commercial, for residential, for Manual J, for AHR CLTD, AHR RTS, all of them, you just did worst case. Because the downside to oversizing heating systems is just so much smaller than the downside to oversizing cooling systems.
Right.
You oversize a cooling system, you're in big trouble. You oversize a heating system,
But worst case is the design day, right?
So worst case is the design day, but load calculations are not as simple as just conduction. A little bit of convection, a little bit of radiance. Thermal mass is a thing, right? And internal loads are a thing. And how those things interplay, and thermal mass can have effects that last hours or days, right? And so if you had a cold snap and it was just overnight and then warmed back up, it was 20 degrees below zero, the next day it's back to the single digits and teens, that might not have a bad impact on the home, because the thermal mass of the home might get you through that. But if you had a cold snap that lasted a week, then you might be in bigger trouble. And when you look at cooling loads, during the day to overnight, there's always a big cyclical swing. That swing is a little bit less in coastal areas, a little bit more
less in
drier
Florida.
climates. Yeah, less in Florida for sure. But it still exists, right? It's still there. Wintertime, you can have overnight lows that are very similar to daytime lows, right? And so you're down here and you stay down, right? And so you stay there for such a long period of time that traditionally engineering has just taken those effects and chucked them out the window, right? And that explains a really good chunk of why we have systems that when we're doing, I can't name chapter and verse the studies, but I've seen a bunch of them where they are finding somewhere between 30 and 60 was the winner of the highest number. Now that 60 was not
30 and 60%
oversized if you compared runtime to the Manual J load.
And
Here's
mine
runtime.
is
Here's
100% though. Mine was 100% oversized.
Sure.
This example.
On a day.
Oh, so you're like average though.
Right. On average, right? And well, no, actually, in specific instances they've studied, and in order for the good studies, we're cherry picking weather events that were cold for days.
Yep.
Right.
That's
Because
what I
if you did a thing that was cycled up above your design temp periodically, then it would be pretty invalid. So we know internal loads are we've removed the thumb from the scale. Right. We know they're there, but we can't really guarantee them. Right. The joke I usually tell is heating loads, the power's out and it's midnight and the sun's because solar gain. I don't even list solar gain. Right? Every day during the day, I'm going to have a source of heat. The problem, cloudy days, right?
Yep.
And so
It's
again,
like
because cloudy days are a thing, they just chuck it, right? But as you will know from any knowledge about solar, the cloudy days don't get you zero, right? There's still radiance happening, right? You can tell the sun rose, except on the worst weather conditions. And so there is some amount, but nobody's ever really bothered to be like, what would be a reasonable amount of this to take care of? Because one, it's easier to design, it's easier to throw away, the consequences weren't there. And two, well, night's gonna come, right? But the thing is when you take those two things together and you map it out over using thermal mass and looking at what the actual heating needs of the building are, and it kind of smears out across time, nobody's bothered to do that.
And I have experienced that in the tiny house and then in our new house. I don't think thermal gain or thermal mass is part of the calculation in cooling season either, right?
No, it is.
Oh, it is?
Yeah. Thermal mass is part of the... So to varying degrees.
Okay.
Your CLTD groups for walls in particular are a source of that. So if I have a heavier wall, it will have a CLTD group that has a letter that's deeper into the alphabet. And if you look into the tables in the Manual J, you actually adjust your delta T down, right? You just, so Manual J has these things called HTMs, they're heat transfer multipliers. It's a kind of a made up number.
Getting nerdier as we go.
I'm a guy, yeah. So the HTM is an analog for the temperature difference and the U value, right? And so what it actually does, just to be precise, is it adjusts the HTM level. But it is to account for the fact that heavier thermal mass will hold heat better. And it uses a table accounting for the daily range of the area. So like when I teach a class, I will often tell, if I'm in Denver, I will say, the difference between brick and siding on your walls, it's not nothing. Right? Like you might want to keep an eye on it. And if I'm in Florida, I go, yeah, there's technically a difference. You're barely going to see it. Right, because there's a very small daily range in Florida and a very large one in Denver. And the Manual J is sophisticated enough to have effects that are tied to that daily range. So that the more it heats up and cools down, the more your wall is starting off cooler and has to travel that distance to get warmed up. And the more the temperature stays steady, the less it has to get to peak, and so the less effect it's going to have.
And so we can trust the Manual J is doing that in cooling season, but not in heating season.
Not in heating season.
And do we care is the question in heating season. They have decided we don't.
Yeah. Well,
and they're not, are they talking about it?
It's not ACA, it's like all the way up, like all the way back to Willis carrying, right? Like this is a fairly, cold climate heat pumps is a fairly new thing. It's presenting this kind of a fairly new problem, and people are taking cracks at it, mostly I think at the ASHRAE level, but that's usually how it works, right? They commission a method. Actually, I don't want to pretend I'm an expert on that process, but it tends to flow from ASHRAE down to ACA and other things like that. You might see some of the energy groups have, like your ResNets and Title 24s and Porta 405s will have factors for this because they're actually modeling hourly across the year. And so they may actually be taking that into account a little bit better. I'm not an expert on that methodology, and it's actually kind of difficult. It's not like there's a...
That might be why, I mean, I've seen very stark differences between a Manual J calc and a rem rate calculation for like sizing.
Yep, that could have something to do with it.
All right, this conversation will continue. And there went 2 days. Comment, like, subscribe. Tune in next time.